I'm Friedel. I'm going to be talking about tracking file provenance with parsl. So what is file provenance? So it's the information about when a file was created, how it was created, what function created it, what inputs were given to the function, what environment was used, what was the conda environment, what packages were used, what environment variables might have affected the processing of the file, and potentially what other functions in the workflow use it. So file provenance is kind of the encapsulation of all of this information. So what use is it? Well, let's say you've got a workflow that has dozens or hundreds of tasks even that might loop in time steps. So the function is getting called many times, producing a large number of files. Sometimes you might want to run it with different input parameters to see what the different things will be produced, what things converge, what things don't. And so you come back, in even a week or a couple of months, and you look at the results and you say, okay, I've got file X, how did I create it? What went into this? And if you took meticulous notes, you could probably figure it out. But in general, it's time consuming and problematic to kind of tease it all back out. So this is where the file provenance tracking comes into play. So we utilize the existing monitoring framework to identify all of the input and output files going into each function and capture the information about them, their size, timestamps, etc. We capture what task created it, what tasks used the file, what input arguments went into the different functions, and also captured as much about the parsl execution environment as possible. For example, looking at the worker init inside the provider. And then we use the existing parsl monitoring visualization tool to be able to create a web interface for looking at the information that was gathered. And to enable the file provenance tracking, you just need to add the monitoring stuff to your config. And really, the only one that's required is to capture the file provenance as true. Most of these with their default values will work fine. And you can let it run, and then you can pull up the parsl-visualize. So here you can see the workflow which uses the tasks, what files went in, what files were produced. You can also search for specific files with even wildcards to see, if you have hundreds of files and you want to be able to tease them out, you can search the database for them. And then you can with each task, you can see exactly what files were produced. You can click on the files, get the details of when it was created. You can look back at the particular task, and you can also see what the other keywords are. It goes down off the screen, but you can see what all the keyword arguments were. And then you can also click on the environment tag, and it'll tell you, okay, here's the worker init line, and here's the tasks that used it, and the files. You can go through and find the files that were associated with that environment. So this has been a great help in things where we run stuff a lot, or it takes days or months to even do a run to be able to track it all. One thing we came across is what we call dynamically created files. So these are files which are produced by an app, but you don't necessarily know ahead of time that the file is going to exist. You put something in, and the app may create files depending on how long it's been running and things like that, but you don't know ahead of time what number of files, or specifically what files are being created. So when your app, your outputs, you just give it the open bracket, list, and you can append to it. But unfortunately, parsl doesn't technically know about these files. It won't be able to stage them back, because when it's creating the DAG, running through, it sees the empty list and goes, well, there's no outputs coming from it. So what we did was created what we call a dynamic file list. It acts just like a Python list, but it's also a future. So it'll hold the position in the processing until the the particular app is complete, and then the files that are in the output will get properly processed by the data flow kernel. And it allows the apps to rely on files that technically at runtime don't have a reference to them until they're actually created. And it's just a quick example. Here's just a script where up here just creating a random number of output files, and then feeding those outputs into this second app that does whatever to them. It doesn't really matter. So here we create the first call and send it to the list, and then here we only want the first file we know is going to be a log file. We don't need to post process that. So we just say, okay, grab the first one to the end of the list and do stuff. Now, the issue is that your workflow will crash here because when Parsel's creating the DAG, it doesn't see that there's a connection between these two because this is an empty list when it's creating the DAG. So it tries to run them in parallel. And when you try to create, take a list that has nothing in it, starting at index 1, and it doesn't work out so well. But if you use this dynamic file list, you can essentially just substitute it right in, and the workflow will see this as a future. It'll wait for it until it's complete, and then continue the processing afterwards.